Alright, this is Unit 1, Formative 1, Video 3, Real Numbers and the Number System. So we have two ways to represent the numbers, and there's another one on the next slide. But the first one is this one here, which is our natural numbers, which is the inside of the Venn diagrams. Natural numbers are numbers just 1, 2, 3, 4, 5. No zero, no negatives, no fractions. Okay? And then the next one that we go out are whole numbers. So whole numbers have natural numbers and zero. Okay, and then up here at the top one, again we have natural numbers, and then a whole number is zero and natural numbers. Then our next one's integers. Okay, so our integers are natural numbers, whole numbers, and negatives. Okay, so even down here, integers are natural numbers, whole numbers, and integers. So that gets our negatives in there. Then the next one, which represents a lot of numbers, as you can see by this orangish circle and down here at the bottom, are rational numbers, are all natural numbers, whole numbers, integers, and numbers that can be written as a fraction. Okay? So just remember, whole numbers can be written as a fraction, natural numbers can be written as a fraction, because you're just going to put a 1 under them. Okay? And then you have numbers that aren't whole that still could be written as fractions. So you have like 5/3, then you have 63/100ths, and then here you have repeating decimals. Okay, all those are called rational numbers. They can be written as fractions. And then the last one, or which is the other part, okay, so this is sometimes the easiest thing to do, is irrational numbers, over here on the right and in the other yellow circle. Rational numbers are numbers that cannot be written as a fraction. Okay, so that means a non-repeating decimal. Okay, never-ending, non-repeating decimal. So the best example that you guys probably heard of is pi. Okay, also up here you can see most square roots or radicals are irrational numbers. But be careful, square root of 4 is 2. Okay, so that would be down here in the naturals and the rational numbers. So, but the square root of 5, if you take the square root of 5, it's a never-ending decimal, so that would be an irrational number. Okay, and here's just another way to look at this. I think this is the one that's on your video notes. Okay, but again, it's the same thing. It's a Venn diagram. All right, what integer is closest to square root of 53? Okay, we're not going to get a calculator for this. What you need to do is you need to figure out what we call perfect squares. So we have perfect squares. Perfect squares are like 1, 4, because if I take the square root of 1, I get 1. If I take the square root of 4, I get 2. And then 9, square root of 9 is 3. Square root of 16 is 4. Square root of 25 is 5. Square root of 36, 6. Square root of 49 is 7. Square root of 64 is 8. Okay, and then so on. Square root of 81 is 9. What we want to know is, where does the square root of 53 fit in here? Okay, well, it fits in here somewhere. Okay, and what it's asking is what integer. So an integer means not a fraction, not a decimal. Okay, just a number, positive or a negative number. Okay, so 53, would it be closer to 49 or 64? Well, 53 is closer to 49, so when it asks what is the closest integer to square root of 53, our answer is going to be 7. Okay. Right? And that is a good way to estimate. And like on the ACT, when it asks you to estimate and stuff like that, that's what it's asking. Okay, so you got to know your perfect squares for that. All right, next one. What is the order of square root of 6, negative 3/10, negative 6/5, 1.5, and square root of 3? And they want it from least to greatest. Okay, so the easiest way to do this is to make all your numbers decimals. Okay, so we're going to take the square root of 6. Okay, and I'm going to go out about 3 decimal places just to make sure I don't have to go back and redo anything. And I get 2.449. Okay, and then negative 3/10 is already in a decimal, so I'll have to do that one. And then 6/5, I'm just going to take 6 divided by 5, it's negative, and I get negative 1.2. Okay, and then 1.5 is already in a decimal. And then square root of 3 is 1.732. I'll just need that, okay. All right, so from least to greatest. Now we changed them all to decimals, but you need to make sure your answer is in form of the original question, okay? So my smallest number, okay, is going to be negative 1.2, okay, which is the negative 6/5. Okay, I'm going to cross it out so I know you used it, okay? My next smallest number is the other negative, okay, and that's in the same form. It was a decimal. Okay. Now my next smallest number is going to be 1.5, and that was in the decimal, so I can leave it. And then now I have 1.73, which was square root of 3. And then last one was square root of 6. Okay, and then that's my answer from least to greatest. All right, next one, what is an inequality? So that's your less than or your greater than, that compares the numbers square root of 54 and 7.5. Okay, so let's go back real fast. Square root of 54. Let's figure out what square root of 54 is. Again, when we compare these, the easiest way to compare them is with decimals. So I'm going to take the square root of 54, and I get 7.34. Okay, and then I have the 7.5. Now I want to put a less than or a greater than sign there. So 7.5 is bigger than 7.34. So I want this one, square root of 54, is going to be less than 7.5. Okay, and that would be my answer.